Okay, gonna be working these problems. Make sure I'm sharing my screen. I am. Okay, so working 4.5 quadratic inequalities. Solve the following inequality. So what we're going to do here is to solve any inequality. First thing we're going to do is, or quadratic inequality, is we're going to move everything to one side, which it already is, and then we're going to treat it like an equation and solve this quadratic equation, which we should know how to do from the previous section. I believe this factors. So let's see, we need two numbers that multiply to be 48, but add up to be negative 14. So let's see, negative, what do we got here? 4, 12, no, 4 and 12 don't work. 6 and 8, yeah, 6 and 8. Okay, why did that take me so long? So minus 6, x minus 6, x minus 8. So negative 6 and negative 8 multiply to be 48 and add up to be negative 14. So we get two solutions here, 6 and 8. So once we have that, we can go to our XY axis or X axis. That breaks our number line up into 3 regions, and we just have to figure out whether or not the original inequality is true or false in each of those 3 regions. And there are 2 ways to do this. One way is just pick test points. So pick any point here, like 0, let's say, 7 and 9, and plug those into that original inequality and see if you get a true statement. So I'll just try it with 0. So if I plug in 0 into that, I get 0 squared minus 14 times 0 plus 48 less than 0. So is this true or false? Well, that's 48 less than 0, and that's not true. So that means nothing over here works. If we do the same thing for 7 and 9, we should get yes, it works, and then no, it doesn't. So that means our answers are everything between 6 and 8. Okay, and then we do not want to include 6 and we do not want to include 8, because if we try and plug in 6 or 8, we're going to get this equal to 0. Oh, continue. Hold on. We're going to get equal to 0, and we want this thing to be strictly less than 0, so we don't want the 2 endpoints. Now, the other way to do it is to realize that when you do this quadratic equation, that this is a parabola that opens up, because this 1 in front, we know it opens up. And so these 2 points, 6 and 8, represent x-intercepts. So we know that the parabola goes down and comes up like this. And so to ask where this thing is less than 0 is asking where is this graph below the x-axis, which would correspond again to the same answer. So either way you do it, I like the second way, but you know, either way will get you to the same result. So it's everything between 6 and 8. So let's go ahead and put that in there. The solution set is interval notation. So we want from 6, to 8. There we go. Okay, same thing. We're gonna set this one up. So move everything to one side, which it already is, set it equal to 0. Fortunately for us, this factors. And then we can set each of those equal to 0, and we get 2 answers, 0 and 6. We do a number line, here's 0, here's 6. And I'm gonna go the fast way again. I know that this is a 1, I know this parabola opens up. So I know it goes like this, comes through like that. These are my x-intercepts. So we wanna know, pay attention here to, we wanna know where it's greater than 0. And that means that we don't want it to be equal to 0. So we don't want 6. Don't want to include, but we want everything to the right, because that's where our graph is above the x-axis, greater than 0. And then everything over here too. So don't include 0, but go this way. So that in interval notation is negative infinity to 0 union with 6 to infinity. Okay. All right, next one. X squared minus 36 less than 0. So x squared minus 36 less than 0. I turn it into an equation first. I can do this two ways. I can factor the left side, x plus 6, x minus 6. Or I could just move the 36 over and take the square root and do plus or minus. I'm going to do it this way. I got two answers, -6 and 6. Set those both equal to 0. So on my number line, I have -6, I have 6. Here with this quadratic, again, it opens up. So I know it goes like this and comes through like that. And let's see, I want this to be strictly less than 0. So that's going to be over here. And I do not want to include 6 and -6 because that's where it's equal to 0. So I get that. So everything between -6 and 6. All right, next one. So we have x squared minus 3x plus 9 less than or equal to 0. I'm going to make an equation. Now, unfortunately, this does not factor. So I'm going to try and use my quadratic formula here. So x equals -b plus or minus the b squared minus 4. B squared would be 9 minus 4 times a, which is 1, times c, which is 9, all over 2 times a, which is 1. And what you're going to notice here is we're going to get 3 plus or minus square root of 9 minus 36. And at this point, we realize that this is going to be a negative number, and I cannot take square root negative. So there's no solutions here. And what that tells me is that this parabola never hits the x-axis. Okay, but if it never hits the x-axis, right? If this never hits the x-axis and it opens up, then it must be above the x-axis, right? Must be above, because if it were below and opened up, I would hit twice. Can't do that. So this means that my function is always above the x-axis, which means it's always positive. And they're asking, when is it going to be less than or equal to 0? But it's above the x-axis, so it can never be 0 on the x-axis, or it can never be down here. So there should be no solution to this. All right, so this one's a little bit different, because the first thing we're going to have to do is we're going to have to get everything together on one side. I'm going to turn it into an equation first, and then distribute the 3 through. Move the 8 over, 8x, sorry. And then try and factor. I think we get some factoring here, x, 3, 3, and then we should get, let's see, plus minus 1, I believe this works, 3x squared plus 9x minus x, that gives you 8x, and then minus 3. So that's good. And set these equal to 0, you should get 1/3, and then you should get -3 as your solutions. Make sure I put these in order. All right, this is where it's equal to 0. This is a parabola. There's a 3 in front, opens up. So it goes like this, goes like that. And we want to know, let's see, where it is greater than, right? This was this symbol here. So that means I wanted to know if we moved everything over when this is greater than 0. So if it's greater than 0, that means it's everything this way, because that's where it's above, and everything this way, because that's where it's above. And I do not want to include these, because that's where it's equal to 0. So it should be everything from -infinity to -3, comma, everything from 1/3 to infinity. Uh-oh. Well, what's going on here? Positive 1/3, -3. Oh, I forgot to put union. Oops. Let's see if I can go back in there. I did not put union. I should have put union. There we go. All right, next one. What is the domain of this function? All right, so for the domain of this function, we need to make sure, since it's a square root, we need to make sure that what's underneath it can never be negative. So that means it has to be greater than or equal to 0. So that's a quadratic inequality. So first thing I do is I make it an equation. I solve it. This one I'm going to do the way I did not do the other one. I'm going to move the 144 over and then do square root on both sides. So you get x is equal to plus or minus 12. And so you have two answers, negative 12 and 12. And I'm wanting to look at this as a parabola that has a 1 in front of the x squared, so it opens up. And this time I want to know where it is greater than or equal to 0. So I'm going to include these points, and it goes up here, it's greater than, so it's everything out this way. And I'm going to include negative 12, and I'm going to go this way forever. So that should be from negative infinity to negative 12, bracket, because I want to include negative 12, union with bracket 12 comma infinity. There we go. All right, pause this real quick. All right, so use the functions f of x equals x squared minus 1 and g of x equals 2x plus 14 to answer parts A through G. All right, first part, solve f of x equal to 0. So we're going to take the original function f, set equal to 0. I'm going to factor that as a difference of squares and get two answers, negative 1 and 1. So my answers here are negative 1 comma 1. All right. Part B, where is g of x 0? So here we take the other function, 2x plus 14, set it equal to 0, subtract 14, divide by 2, you should get negative 7. Okay, now they want to know where is f of x equal to g of x. So for this, I'm going to take f of x, set it equal to g of x. And so now I'll move everything to one side because it's quadratic. So I subtract 2x and I subtract 14. So that'll give me minus 15. And then hopefully we get a factoring here. 15, 3, and 5. So x plus 3x minus 5. And so we get two answers here, negative 3 and 5. All right, next one, they want to know where are we at? We're at D. They want to know where is f of x bigger than 0? So where is x squared minus 1 bigger than 0? So since we already found the two solutions from part A on this, we know it's at negative 1 and 1. And we know it's a parabola that opens up because there's a 1 in front of x squared. We want to know where it's greater, so that's over here and over here. So that would be from negative infinity to negative 1, not including negative 1, union 1 to infinity. And I'm just going to go to part E. Part E says, where is g of x less than or equal to 0? So I take the g function, so 2x plus 14. I ask, when is that less than or equal to 0? This is just a regular inequality, so I can move the 14 over to the other side and divide by 2. So you get x is less than or equal to negative 7. That's for part E. This is part D. Okay, for F, I want to know where f of x is greater than g of x. So they want to know where x minus 1 is greater than 2x plus 14. But if we move everything to one side, we have a quadratic inequality. Now this looks like part C, where we set them equal to each other and we got that quadratic. We said that the two solutions here were negative 3 and 5. And the parabola opens up like this. So we want to know where the f was greater than g, so where this is greater than 0. And so that'll be this way and this way. Oh, I should have put here x is less than -7. I should have put negative infinity to -7 like that with the bracket on the 7. It's everything to the left of -7, including -7. And then this piece right here, negative infinity to -3. Don't include -3. Union 5 to infinity. All right, I'm not going to type those answers in. I feel good about them. So last one, they want to know when is f of x greater than or equal to 1. So that means they want to know when is x squared greater than or equal to 2. Add 1 to both sides. I take that back. It's quadratic. Move everything to one side, make an equation. And now I'll move the 2 over to the square root. You get x is equal to plus or minus √2, which on a number line is negative √2, positive √2. That. And it's a parabola that opens up. So it goes through like that. And we want to know where it's greater than or equal to 0. So we're going to go everything to the left, including negative √2, everything to the right of √2 forever. All right, that should do it. I'm not going to put those in, but that should at least, oh, that's it, I guess. That's it for this problem. So see if there's another one after this. Okay, so last one here. A ball is thrown vertically upward with an initial velocity of 64 feet per second. The distance s in feet of the ball from the ground after t seconds is given by this formula. This formula tells you how high the ball is off the ground after a certain amount of time. Here's a picture. Ball's thrown up, comes back down. Okay, at what time will the ball strike the ground? So part A is really just asking, when will s be 0? So when is that going to happen? Well, all we do is set 64t minus 16t squared equal to 0. We can factor here, we can pull a t out. I'm just going to pull t. And then set both of those equal to 0. So I get t is 0. Then here, if I set that equal to 0 and move the 16t to the other side and then divide through by 16, I get 4 for t. So when is the ball going to hit the ground? At either t is 0 or t is 4. So 4 is what makes sense because when we start, the ball starts at the ground and then it goes up and comes back down. So 4 seconds. And then the next question is for what time is the ball more than 28 feet above the ground? So they want to know, using this formula, when is this height of the ball bigger than, more than 20 feet? So bigger than 28 feet. So they want us to solve this quadratic inequality. So I'm going to move everything to the right side. So I get 16t squared will be positive. I'll get minus 64t plus 28. Okay, and I think we've done enough of these that you can solve that from here. And that'll be your solution. All right, that's good. I'm sorry I've got to go, so I'm kind of rushing through this, but I think that'll be enough for you to get through it. So, all right, hope that helps.